Hey, this is page 3 of your unit circle packet, so you should have pages 1 and 2 completely done. If you don't, make sure you complete them first and then go back and look at the answer key on the previous day's pages. Alright? Because you need to know that stuff in order to move on and do this stuff. So today what we're going to look at are 30, 60, 90 triangles again, and today we're actually going to force this hypotenuse to be 1. All right, for all of these triangles. And the first triangle and the third triangle, they're the same triangle. They're both 30, 60, 90 triangles. They're just in different orientation. Okay? And there's a reason for that, and we'll get to that. All right, so here's what we're going to do. We are going to force that hypotenuse to equal 1. Now, in order to do that, we still need to recall what our ratios were. So let's think about that for a second. If our ratios of a 30, 60, 90 triangle are, do you remember what they are? You might need to get those ratios out again. But remember, this was like our 1a. The hypotenuse was double that. This was our 2a. And this was our a square roots of 3. So right now what we know is that 2a is equal to 1. So we're going to set 2a equal to 1. And when we solve for a, we realize that a has to be 1/2. So this length AC has to be 1/2. So I'm going to erase the 1a there. And the a square roots of 3, well, again, if a is 1/2, we're going to replace that a with 1/2. So BC is 1/2 root 3, or 1/2 radical 3. All right, and then when we get to this last side, AB equals 1 makes sense because if I double the short side, I get the hypotenuse. So this triangle works out now. Okay, so we have created our 30, 60, 90 triangle that has hypotenuse equal to 1. Now, since the first triangle and the third triangle are actually the same triangle, we know that the short side here, the side opposite the 30, has to be the same as side AC over here. So this is going to be 1/2. And we know that side AC right here has to be the same as BC on this triangle, so this is going to be 1/2 square root of 3. Now, we're going to rewrite this actually square root of 3 over 2 because it's just a little bit less work. So we're going to use this for that value. Okay, now let's go to our 45, 45, 90 triangle. For our 45, 45, 90 triangle, we know that our ratios were 1a, 1a, because these two sides were congruent, and then if we use the Pythagorean theorem, we got a square roots of 2. So right now we need to set a square roots of 2 equal to 1. So if we set a square roots of 2 equal to 1, we solve for a, we divide both sides by the square root of 2, a equals 1 over the square root of 2. But we have that rule, we're not supposed to have radicals in the denominator, so we need to rewrite that as square root of 2 over 2. So this is going to be our AC, or our 1a. A equals root 2 over 2. Okay, same with this. BC equals root 2 over 2. And if AC and BC are root 2 over 2, that's going to create this to be 1. And we can do a quick check for that. If we do root 2 over 2 times square root of 2, because we're replacing this a with root 2 over 2, what happens here is we get root 2 times root 2 is root 4, which is 2, and 2 times 1 is 2. So it works out. Okay, so we've got this all figured out, which is kind of nice. We're going to use these values to superimpose these triangles onto our grid below. So what we're going to do is we're going to take these three triangles and redraw them on the coordinate plane below, such that point A is on the origin. So what we're going to do is we're going to let point A be here. We have a radius here of 1, or the hypotenuse, AB, right? That's equal to 1. AB here is equal to 1. These should be equal, but this triangle is drawn a little smaller. And AB here is equal to 1. Okay? So we're going to make sure that point A is on the origin, and side length AC sits on the x-axis. Remember that the hypotenuse is equal to 1. All right, so let's go ahead and do this. I'm going to take my first triangle and I'm going to put it onto this coordinate plane. So I need to go left 1/2 up square root of 3 over 2. So I'm going to go left 1/2 up square root of 3 over 2. And let's estimate what that is on our calculator. I think it looks like it should be right about there. So when you get a decimal approximation for this, you get about 0.866 or 0.87. So this is 0.25, 0.5, 0.75. So that looks about right. Okay, so right now what we have here is this is our first 30, 60, 90 triangle, and we've drawn it on our coordinate plane. So right now this point is the point. I've gone right 1/2 and I've gone up square root of 3 over 2. So I'm going to write that ordered pair right next to that point. We're going to go now to our 45, 45, 90 triangle. We need to go over square root of 2 over root 2. Excuse me, we need to go to the right rad 2 over 2 and then up rad 2 over 2. So let's put rad 2 over 2 in our calculator and see what we get. I got about 0.707, so it's a little bit less than 0.75, so I'm going to estimate that to be right here, and then 1, 2, 3, that's 0.75, so it's going to be a little less. So we're going to estimate that to be right here. That would be our ordered pair approximately, again, is going to be rad 2 over 2, comma, rad 2 over 2. And then we're going to do the same thing with our last triangle. We're going to go right square root of 3 over 2, and then we're going to go up 1/2. So we know we need to go up to this 1/2 line, but we before said rad 3 over 2 was about 0.87. So here's 0.75, 0.87 is right about here. Okay, so this would be the point rad 3 over 2, comma, 1/2. Now, we're going to draw these triangles in so we can see a little bit better what's going on here. And if you look at this, this is kind of a nice, pretty array. In fact, if I took a compass, I don't have one handy, but if I did, I could, and let me get a different color so it's a little bit more pronounced, I could take and draw a circle or the arc of a circle, and it would hit those points. This we call the unit circle because the radius is equal to 1 unit. We go 1 to the right to get to this point, which is 1, 0. We go 1 unit out here to get to this point, rad 3 over 2, comma, 1/2. And same thing to get to this point, and then finally up to this point, which is our 90 degrees, and this is the point 0, 1. All right, so this is our unit circle just in quadrant 1. Let's think about what this means. So I'm reading right here. If segment AB and point A were parts of a circle, AB, and that's this piece right here, AB would be the radius, and A would be the center of the circle. Okay, so if we think in terms of circle, we now have a radius and a center. The radius corresponds to the hypotenuse in our special right triangles. All right, and then we kind of talked about what would happen if we used a compass. All right, this is pretty cool because now all of a sudden we have the values for 0 degrees, which is this segment AB. If I don't make an angle, I have a 0 degree angle. That's where that one lies. And if I have a 90 degree angle, I'm going to go up to the y-axis. This would be the 90 degree angle. So we've got the points for the 0 degree angle right here and the 90 degree angle right up here. Okay, so if we're going to answer number 3, I think we're in good shape because if we treat this as a quarter of a circle in quadrant 1, we've got our radius and our center, and our 0 degree angle would correspond with the point 1, 0. And our 90 degree angle would correspond with the point 0, 1. Okay, we're going to do that the same for the 60 degree triangle. Now remember, when we go to the 60 degree triangle, we need to go up to this 30, 60, 90 triangle, and the endpoints are 1/2 rad 3 over 2. If we go to the 45 degree triangle, we're going to this second triangle that we made, and the endpoints of that triangle are rad 2 over 2, rad 2 over 2. And then for the very last triangle, if we look at that, the endpoint of that radius is rad 3 over 2, 1/2. Okay, so make sure you have this page filled in before you go to the next page, and we're going to have a new video for the next page.